All right, so remember the negative exponent rule says take the reciprocal of the base and make the exponent positive. So the 2 to the negative x became 1/2 to the x, so the base is between 0 and 1. It's a decreasing function. If I have a half to the negative x, when I take its reciprocal, I end up with a 2 to the x. So that turns that into an increasing function. Similarly, 5 to the negative x became 1/5, which is between 0 and 1, so it's decreasing. And then 3/2 became 2/3 with the x becoming positive. 2/3 is again between 0 and 1, so that's a decreasing function or exponential decay. All right, the next question, you're going to match the equation to the appropriate graph. So I've given you 1, 2, 3, 4, 5, 6 different equations here, and we have 1, 2, 3, 4, 5, 6 different graphs. So I assume there's a one-to-one relationship when I made this up. Take a chance, do some guessing, and then you can check. Okay, 2 to the x compared to 5 to the x, these are both exponential growth. So I'm going to use my process of elimination here. These are both growth. This would become a 1/2 to the x, so that will be a decay, decreasing graph. The negative on this one is going to reflect my increasing graph over the x-axis. Similarly, this is an increasing graph reflected over the x-axis, but its y-intercept was originally at a 2 before it was reflected, but then once it reflects, that y-intercept should be -2. So E, I'm working process of elimination. This should be our graph E. The second last graph here, it has a y-intercept at +3 here. If I look, and it's exponential growth because my base is a +2. So B here has that y-intercept at 3. So this should be graph 3. The other reflected graph was graph F. So that takes care of the third last one. The only decay one that we have is graph A, decay in terms of not being reflected, looking at it that way. And then to compare the 2 to the x and the 5 to the x, they're either going to be C or D, and since D has smaller growth or less quick growth than C does, its base is closer to 1. So this should be graph D, and the quicker growth should have a higher base. It's graph 5 to the x is graph C. The back side here, now you have a job of identifying what the y-intercept is for each one of these functions, whether it's increasing, whether it's growth or decay, and I just noticed I have a typo on my copy here, and what the actual percent increase or decrease is. So let's look at this very first function together. We know that the number in front of the base, which isn't actually written here, but it would go right here, that would be, in this particular example, would be the number 1. So our y-intercept would just be 1, 0, or sorry, 0, 1. The y-intercept is just at 1, and if you want to write that as an ordered pair, the 0 comes first because that's the x-coordinate. Boy, oh boy, I'm having a hard time making my stylus do what I want it to do here. There we go. Now, because the base is greater than 0, my exponent is a positive, I know that this is an increasing graph. So I'm going to just show that, or you can do like a picture of the whoosh like that if you wish to show it's increasing. Now, the percent increase or decrease, we know that the base is equal to 1 plus that percent that it's increasing or decreasing by. Since my base is 2, and you don't need to show this step for each one, but I'm just showing that in here. If my base was 2, I know that 1 plus the percent increase has to equal 2, so that means my percent increase is 1 or 100%. Okay, so you can make a little equation to solve if you need to come up with that actual percent growth or percent decrease. Let me just see here. I'm going to slide down to example K. I'm going to do that one with you as well, and then you can do the rest on your own. The initial value is right here. It's 32,000. So we could be talking about the value of a vehicle, $32,000. The base, my exponent, is a positive value. My base is between 0 and 1, so this is a decreasing graph. And to get my percent decrease, then I would say that 0.85 is going to equal 1 minus the percent increase or decrease. Okay, so I just have a percent symbol there. So if I want to get the percent symbol by itself, I could subtract 1 from both sides. So 0.85 subtract 1 would equal negative percent. Okay, you could put a variable there if you would like. And that's going to give me negative 0.15 is equal to my negative percent. So my percent decrease would be 0.15 or 15%. So it's a 15% decrease. Okay, so you fill in the rest here. And again, I didn't leave enough room to show all the calculations, so you might want to, you can just do those off to the side or in your head there. I'm just going to rewrite that for you to be able to see what I had there. So in the end, we had a 15% decrease. Okay, give that a whirl, see how you do. Let me know if you have any questions with that. Okay, use what you know about exponent rules to determine which of the following are equivalent to one another. So I've given you 8 functions here. You're going to play with these and see what end up being the same using those exponent rules that we learned earlier. Now, I'm just going to point out that this very first function right here, y equals 2 to the x, that's pretty basic, pretty simple, pretty straightforward. There's not a lot I can do in terms of exponent rules. However, when you start looking at some of these other ones, there's some things we can do. For example, the number 4 here could be written as a 2 to the exponent of 2. And then we have multiplied by 2 to the exponent x, take away 2. So now we have expressed this where our bases are the same and we're multiplying. And we know the rule is when the bases are the same and we're multiplying, we keep the base as it is and we add the exponents together. So I have my 2 plus the x take away 2. Oops, there we go. All right, now if I simplify that exponent, I have 2 plus x take away 2. Well, if I have 2 and I take away 2, they undo each other, and I'm just left with 2 to the exponent of x. So this one, y equals 2 to the exponent of x, is the same. So this one is equivalent. Okay, this original function, it's equal to y equals 2 to the x. All right, try that with some of these other functions. See if you can come up with some exponent rules to apply to that to see if they're equivalent or not. And then there's a part B that you can try as well. Okay, 1/4 could be written as 4 to the negative 1, and 4 really is 2 squared. Goodness, so 1/4 could be written as 2 to the negative 2. And then that's multiplying the 2 to the x plus 2. The rule is keep the base and add those exponents together. If I have a negative 2 and I add 2, that's just going to be 2 to the x. So once again, I have another one that's actually equivalent to the original function, even though it looks very different. All right, 1/2 to the negative x, I'm going to apply the negative exponent rule, take the reciprocal of the base, make the exponent positive, and voila, we have another winner. Winner, winner, chicken dinner. Anybody hungry? Let's see what we've got for the next one. Y equals 4 to the exponent x over 2. Well, 4 is the same thing as 2 squared. So I've just replaced the 4 with the 2 squared, and that has an exponent of x over 2. Now the rule is when I have an exponent to another exponent, I'm going to multiply those two exponents together. So 2 times x, darn it. Let me try that one more time. Try it again, Sam. No, let's play it again, Sam. If we have 2 times an x over 2, the rule is multiply the tops together. You're going to get 2x divided by 2. The 2's are really canceling out here. 2 divided by 2 ends up being 1. So that's just equal to an x. So that equals 2 to the x. Well, what do you know? Don't assume, though, these are all going to be equal. I'm not going to guarantee that. All right, let's check the next one. 1/4, we already did the work with 1/4 earlier. We knew that that was 2 to the negative 2. And then that's going to multiply 2 to the exponent 2x. The rule is the bases are the same. We're going to keep the base and we're going to add the exponents. I have a -2 plus 2x's. Ooh, terms are not like. That's as far as I can go with this one. This one is not the same. Okay, so that one I'm crossing out. Not the same as the other ones. Let's try the next one. 64 is the same thing as 2 to the exponent of 6. And that's all to the x over 6, which from my work earlier, I know that that's going to equal 2 to the x. It's very similar to the one over with 4 to the x over 2. So here's another winner. All right, next one, 8. 8 is the same thing as 2 to the exponent of 3. And then that's multiplying 2 to the exponent of x. Take away 3. Add those exponents together, and look at that. We've got a 2 to the exponent of x. So, 7 out of 8. That's pretty good. All right, try the next one.